Welcome to MOVITRAC LTP-B Basic and Intermediate Training. This is our final session, session number 13. Our last two sessions were pretty heavy. We learned a lot about field buses and some very advanced information about controlling a MOVITRAC LTP-B. This session is going to be a little easier. It's a nice one to wind up the class on. We're going to be looking at something kind of interesting, and that is how to connect a permanent magnet synchronous motor to our VFD. Now, we have been working with asynchronous motors, also known as AC induction motors or squirrel cage motors. They are the most common kind of motor, but the permanent magnet synchronous motor offers some definite advantages, and the fact that the MOVITRAC LTP-B can control it is actually rather unusual. So let's begin by talking about this kind of motor, how it works, how it differs from the AC induction motor, and we're going to see how to get one connected up to our MOVITRAC LTP-B. Let's talk about a few facts about synchronous motors. Permanent magnet synchronous motors differ from AC induction motors in one key way. They do have the regular stator coils that develop the magnetic field that causes the motor to turn. However, their rotor is significantly different. Instead of having a coil built into it, as in the AC induction motor, they have permanent magnets attached to it. So they have their own magnetic field. They don't have an induced field like an induction motor. This causes some differences in the way the motor works, but we really don't need to get into those here. Let's sum up some of the key facts that we should be aware of, however. First of all, in the SEW Eurodrive world, we commonly call permanent magnet synchronous motors servomotors. Now, there are other servomotor technologies based on different motor types, but the majority of our products that we call servomotors are in fact permanent magnet synchronous motors. So I'm going to be using these terms somewhat interchangeably. One advantage that a servomotor has over an asynchronous motor, an AC induction motor, is that they tend to have smaller rotors for the same torque rating, and this makes the motors more compact, so sometimes servomotors are used simply for their space-saving qualities. They also have what is called more dynamic behavior, meaning they can start, stop, or change direction more briskly than an AC induction motor. They can usually produce larger peak torques, and they're often used for precision tasks. You will frequently see servomotors in things like robots and CNC machines or precision packaging machines. However, they can be used just as a general motor when their low rotor inertia is desirable. Because their rotor has a lower mass, it has lower inertia, and that is useful in some applications. Now, an important note. Many VFDs can't control servomotors unless the motor has what's called an encoder or resolver connected to its shaft. This is a feedback device that provides the VFD with speed and/or position information. Some VFDs require this in order to be able to control a servomotor. The MOVITRAC LTP-B does not have this requirement. It can control what we call an encoderless servomotor in speed control mode. Now, we can't do positioning with it. You need feedback to do positioning. Most introductory VFDs, lower-end VFDs, do not support this kind of feature, so the fact that the MOVITRAC LTP-B does offer it is somewhat unusual in its price category. Let me point out a few of SEW Eurodrive's servomotors. We have a number of different product lines, and this is not an exhaustive list, but it certainly covers the main ones. The CMP servomotor series has been around for quite a few years. It's one of our mainstay servomotors, so these are very, very common. You will also see sometimes what is called the MOVIGEAR DSM. This is an interesting combination of a servomotor and a high-efficiency gearbox all in one unit. The MOVITRAC LTP-B is often sold with these to control them, so if you see one of these, that's what you're seeing, a servomotor plus a gearbox. And then we have some newer products that are part of what we call our C generation. There is the CM3C motor. This is an improved servomotor that we have just introduced fairly recently, and it certainly can also be used with the MOVITRAC LTP-B. And then there's the updated version of the MOVIGEAR DSM, which is called the MOVIGEAR Classic. This too has a high-efficiency servomotor and high-efficiency gearbox in an all-in-one unit. All four of these products can be controlled by the MOVITRAC LTP-B. So let's talk about what it takes to get one of these connected up and operating. Of course, connecting up is very simple. You simply connect up the 3 phases and the ground wire. But to configure it to run, you need to gather some key motor data. So what information do you need in order to set up the motor on your MOVITRAC LTP-B? Well, you need 4 basic electromechanical parameters. And if you're setting up a non-SEW servo motor or PM synchronous motor, you'll need to gather this same information from the nameplate or the manufacturer's datasheet. This is what you need. You need the rated speed, the rated frequency, the internal voltage, and the rated current. I'm going to warn you, this information is often not on the motor nameplate, so you may have to get the datasheet or even call the manufacturer's technical support line and ask about this. Let me give you an example to show you how you obtain these 4 pieces of information. I'm going to use an SEW motor, a CMP40S, which I have with my demo unit. I'm going to demonstrate setting it up in just a few minutes. Now this motor, according to its nameplate, has a speed class of 4,500 RPM. Servo motors usually are rated by speed class. For example, 2,000 RPM, 3,000, 4,500, or 6,000. In this case, my motor, according to the nameplate, is a 4,500 RPM speed class, and it has a system voltage of 400 volts. Now our rated speed and our speed class are one and the same, so we have our first parameter already. The nameplate on this motor does include the rated frequency. It is 225 Hertz. Permanent magnet synchronous motors usually have much higher frequency ratings than AC induction motors, which, as you know, are 50 or 60 Hertz, so don't be surprised by the higher frequency. So I got 2 pieces of information off my nameplate. However, these second 2 pieces of information are not on the nameplate. And you might be thinking, well, isn't the internal voltage the same as the system voltage, 400 volts? The answer is no. The internal voltage has to be calculated, and I had to dig into the motor's datasheet to get this information. Now, I needed to look up what was called the open circuit voltage, which is often V sub P0 or U sub P0 in most datasheets. This is a value that has a rather unusual unit. It is volts per 1,000 RPM. So I had to look this up for my motor, and then I do a calculation. You calculate the internal voltage by multiplying this value, V sub P0, times the motor's speed divided by 1,000. So in my case, my motor has a 27.5 volts per 1,000 RPM. What I do is I take this value, 27.5 volts per 1,000 RPM, and I multiply it by my speed divided by 1,000. 4,500 RPM divided by 1,000, and I get 123.75 volts. That is my internal voltage. Now I have to round this either up or down, so I went with 123 volts. And then lastly, I had to get my rated current. I needed to go into the data sheet for this too, because the rated current you're after is not the motor's maximum current, which for this motor is 9 amps. I needed to get what's called the standstill current, I sub 0. And in my case, it is 1.2 amps. So be sure to get the right value. And so this is the information you need to find in order to do a motor startup. Now, there is a convenient little shortcut available to you if you have certain SEW Eurodrive motors. Many SEW Eurodrive servo motors have presets available in LT Shell, and this is the list that's available in my version of LT Shell. Yours may be slightly different, but it should be similar. These automatically set the correct electromechanical parameters. In other words, they save you the trouble of having to look up all the required motor information and do the calculations. However, I will add a caution. Always confirm that the parameters look appropriate and match your motor. Some of these motors do come in multiple speed classes. You may need to tweak a few parameters to match your actual device. So use the presets by all means, but use them with intelligence and caution. This list will certainly grow as SEW Eurodrive adds new motors to its portfolio, so look for this list to change over time. Let me give you a warning that I gave you way back in the beginning of this class when we did our first motor startup. It is always a smart idea to disable your VFD by turning digital input 1 off and inhibit your VFD as well by activating the Safe Torque Off feature. So in other words, remove 24 volts from Safe Torque Off Plus and remove ground from Safe Torque Off Minus. We're going to be factory resetting our VFD, and it's a very good idea to do this because if you don't disable the VFD, the motor can start up immediately after a factory reset. You should always disable it and go through the complete motor startup before removing controller inhibit and enabling your motor. So remember, you have been warned. Okay, well, we're now ready to do a motor startup for a permanent magnet synchronous motor, and we're going to start with the manual entry version. This is the harder of the two startups. You can do this with any SEW Eurodrive motor or third-party motors as well. So this is kind of the long form of it. We'll look at the short form a little later. So let's begin. Here's what you have to do to enter a motor manually into LT Shell. And I do recommend you do this startup in LT Shell rather than the keypad, although it is certainly possible to do it from the keypad. LT Shell is just more convenient. So get into LT Shell and factory reset your VFD, and then enable the extended parameters by setting parameter 1-14 to 201. So just a reminder to factory reset your VFD from LT Shell. Click this button right here. It will ask you, do you want to reset your VFD? Say yes. The VFD will then be reset. At that point then, what you want to do is enable real-time edit and go to parameter 1-14 and set it to 201 because you do need the extended parameters to enter this type of motor. Your next step is to go to parameter 1-16 and change the motor type from standard AC motor, which is what it defaults to option 1, undefined servo motors. So when you click this, you'll get a drop-down list. You want to pick option 1 from this list. Then go to parameter group 4, find parameter 4-01 and set it to option 3, PM motor speed control. So this sets it to the correct mode for a servo motor. Go to parameter group 2, find parameter 2-24 and set it to 8 kHz or higher. This is the PWM switching frequency. You cannot use the low frequency options with the servo motor. It must be 8 kHz or higher. And then finally go back to group 1 and set parameters 1-07 through 1-10 to the 4 electromechanical values that you have already obtained. And then finally, confirm the parameter 1-01 matches parameter 1-10. It should change automatically, but double check that it has. Finally, go through each parameter group that is turned red because that means parameters have changed from default values to other values. And you want to go through these parameters and just sort of eyeball them and make sure they look reasonable. For example, I recommend you go to group 2 and check all the presets, make sure they look realistic. In this case, they do. And then finally, set any optional parameters that you may need to set. For example, I recommend setting the acceleration ramps, the stop mode. You may also want to set a minimum speed in parameter 1-02. In fact, the manual recommends that you set this to about 10% of the motor's maximum speed. So with this motor, which is 4,500 RPM, you would set it to about 450 RPM. In general, the VFD does not control a servo motor at very low speeds very accurately, so setting a low speed might be a smart idea. I also recommend you set parameter 1-12 to keypad mode bipolar just for testing purposes. When you start up your motor, you do want to do a test run. It's easier to do it with the keypad. Once you know everything's working, if necessary, you can change this to something else like terminal control mode or field bus mode. But I recommend starting in keypad mode. And then you will have to do something that we talked about way back in the beginning, and that is tuning the drive. Remember, the MOVITRAC LTP-B can do something called auto-tuning, where it measures the motor's electrical parameters by running a small amount of current through it. This automatically happens after you factory default the drive the first time you try to run it. So this is going to happen here. So just a reminder, before running the motor for the first time, we need to go through that auto-tune cycle. What you should do is remove the Safe Torque Off and enable the VFD by turning digital input 1 on. And just a warning, the motor may move during auto-tuning, so make sure everything is safe before you do this next step. Then press the Start button, and the display should change to Auto T. You'll hear some funny noises coming from the motor. This takes somewhere between 30 seconds and a minute, and eventually it will change to stop, indicating that it's finished. And at that point, you can run the motor. Just a reminder, I told you this way back in the beginning, but you may have forgotten it now. If the auto tune does not run for some reason, you can always force one by going to parameter 4-02 in the extended parameters, and you can trigger it that way. Do this from the keypad. So go to this parameter. It's normally set to 0. If you change it to 1, that will force an auto tune to begin immediately. This is just for your curiosity. Parameter group 7 contains many expert level motor parameters. Auto-tuning sets a lot of these, so these will change to red. You don't have to tweak these yourself. If you don't know what to do with them, I say leave them alone, but occasionally if you have to do something expert level, you may actually have to go into these parameters and make changes, but these are the parameters that auto-tuning will tweak. And I'll just mention, the manual talks about this. It does provide some guidance. You occasionally do have to do manual tweaking to get the motor running optimally for your specific application. So I point you to the manual for guidance, but in many cases, after you've auto-tuned, everything will just run perfectly fine. All right, I think it's time to talk about some practice rather than theory. Let's do a demonstration. All right, for our first startup, we're going to do a full manual startup. You can use this method with any appropriate permanent magnet synchronous motor. I'm going to be using an SEW Eurodrive CMP40S motor with a 4,500 RPM speed rating and a 400 volt system voltage. This particular motor does not have a preset in LT shell, so this is an SEW Eurodrive motor, but I can't use the quick startup with it because it's not available for some reason. So this is a good example of doing a fully manual startup. Now I've already obtained my 4 electrical parameters for it. I showed them to you earlier. I'm going to pop them up here just by way of reminder, and we're going to do a startup around these. Now as you can see, we're in LT shell, and this is where we were after the field bus activity. So the first thing we need to do is factory reset our VFD. And by the way, my VFD is in safe torque off mode. I've turned the 2 switches off, and digital input 1 is also off, so it's showing inhibit. So I go up here to this button here, Reset Parameters to Factory Default. I click it and I say yes. All right, so the first thing I need to do is enable my extended parameters. So I turn on real-time edit mode. Then I go to parameter 1-14 and change it to 201. This unlocks all my parameters. The next thing I need to do is go to parameter 1-16 motor type and change it from standard AC motor to undefined servo motor. So this puts me in servomotor mode, PM, synchronous motor mode. So I do that first. Then I go to parameter group 2, and I need to change my switching frequency to something 8 kilohertz or higher, so I'll change it to 8 kilohertz. This is parameter 2-24. I go to parameter group 4, and I need to change my motor mode to PM motor speed control. And notice it automatically changed there. I think that's because I picked servo motor. But I need to confirm that this has been selected. If I don't, I might have problems. All right, now I go back to parameter group 1, and I need to enter my motor data. So I'm going to just start up here at the top with motor rated voltage. Remember, this is the internal voltage, not the system voltage. In my particular motor's case, it's 123 volts. So I key that in. Then I put in my rated current. This is not my motor's maximum current, which is 9 amps. It's actually 1.2 for this motor. It's the standstill current. I set the frequency. This was on the nameplate, 225. And then finally the rated speed, 4,500 RPM. I go up here and I confirm that parameter 1-01 is also 4,500 RPM, and it is. So this is everything I have to do to get my motor set up to run. I do, however, want to quickly eyeball any parameter groups that have changed from the default values. So parameter group 2, I take a quick look at my presets, and everything is at least within an acceptable range, so everything is fine there. Nothing else here has changed. Group 4 is fine. I'm not going to make any changes to these parameters because they are probably fine. And group 7 are the electrical parameters. These will be modified when I do the auto tuning, so I'm not going to look at these either. I'll go back to parameter group 1. I do want to set a few optional things. I'm going to set my acceleration ramp to 2 seconds, and I'll set my deceleration ramp also to 2 seconds. I'll keep my stop mode on ramp to stop. And I am going to set a minimum speed. I'm going to set it as the manual recommends to 450 RPM, which is 10% of the maximum. Servo motors generally don't run very well at low speeds without encoder feedback. And in this case, of course, we're running encoderless. So this is perfectly fine, especially for testing. The last thing I want to do is change my control mode from terminal to keypad mode bipolar, parameter 1-12. So that is all I have to do. I'm going to turn real-time edit mode off now, and I'm going to go to my VFD. I'm going to take it out of safe torque off mode. I'm going to enable it, and I'm going to try to run it. And as you know, it should run an auto-tune cycle at that point. So let's go over and do that, see if that works, and then we'll try running our VFD and see if we can run our motor up and down. All right, our VFD is showing PDEF. That's because we factory defaulted it. So the first thing we have to do is just clear the message by pressing the stop button. So we'll do that. Now we're in controller inhibit, so I have to remove safe torque off by turning the 2 safe torque off switches on, and then I turn digital input 1 on to enable the VFD. And I'm going to press start, and that's going to trigger an auto-tuning cycle, and you can see it just did. It's tuning. You saw the motor twitch a little bit. It's also making some funny noises. This will take a few more seconds. Eventually, though, it'll display stop, as it does here, and now it's ready to run. So now I'm going to press the start button again, and this time it should run. It should go to the minimum speed, which is 450 RPM. We're on Hertz right now on our display, so I need to press navigate to get the RPM display. There we go. It's 450. Appears to be running fine. Let's accelerate it up all the way to 4,500 RPM just to make sure our motor runs smoothly up to its full speed range. And it seems just fine. Let's try reversing. We'll press start again to go in the other direction. We're decelerating down. And then we'll re-accelerate in the counterclockwise direction. That appears to be going okay. All right, so that worked. Let's decelerate down. And of course, we won't actually be able to go below 450 RPM because that's our minimum we've set. We'll just reverse it though and hit stop. And everything seems to work fine. So I think we've done it. All right, well, we have done a manual motor startup. That is the hardest way to do it. We're now going to look at an easier way. If you have an SEW Eurodrive servo motor and it has a preset available for it in LT shell, then we can do some shortcuts. So this is sort of the easy startup. Let's take a look at this. Using a motor preset is naturally a simpler way to do the startup because it has all the information the VFD needs. You don't have to look up so much and calculate things. So let's outline the procedure. You start more or less the same way. You disable your VFD by triggering safe torque off and turning digital input 1 off. Then you factory reset the VFD by clicking this button right here in LT shell. Once you do that, turn on real-time edit mode and enable the extended parameters by going to parameter 1-14 and setting it to 201. Go to parameter 1-16 right here and change it from standard AC motor, which is the default, to match your motors. So pop up this list, find your motor on the list, be sure you get the right voltage, select that, and it will automatically set all the key electromechanical parameters. Once you've done this, you need to go through every parameter group that is changed to red and take a quick look at the red parameters, the ones that have changed from the defaults. Just make sure they look appropriate. For example, I recommend eyeballing parameters 1-07 through 1-10. Make sure it matches your motor, especially the speed class. Check parameter 1-01 as well. It should match 1-10. If it does, everything is fine. Now in this case, when I went to parameter group 2, I noticed I actually had an inappropriate preset. Parameter 2-04 is set to 4,800 RPM. That is faster than my motor's maximum speed, so I should go in and change that to something lower. Some parameters that have been automatically set may be inappropriate, so you do need to give them a once-over. Double check that parameter 2-24 is set to 8 kHz or higher. Make sure parameter 4-01 is set to PM motor speed control. It should be, but double check it. And notice here, these parameters which are associated with the brake have been altered. If you're using a brake, confirm that these are correct. If you're not, of course, you don't need to worry about that. And then finally, set any optional parameters that you might wish to tweak. For example, the acceleration and deceleration ramps, the stop mode. You may want to set a minimum speed. As I said a few minutes ago, the manual recommends you set the minimum speed parameter 1-02 to about 10% of the maximum, which would be 450 RPM here. Servo motors generally don't run very well at low speed if they don't have feedback, which in our case we don't. We're running this encoderless, so you might want to set that. And I do recommend again that you set keypad mode as your way of controlling the VFD just for testing. Once you've tested it, if you want to change to terminal control or field bus, that's fine. But bipolar keypad mode is a handy way to get started. Now, this is a big difference. You do not need to run an auto tune if you use the SEW Eurodrive motor preset. You don't need to measure the motor's electrical parameters because the preset has already set those. So even though you factory reset your VFD, it's not going to run an auto tune automatically when you try to run the motor. So this is the difference. The VFD is ready to run the motor immediately. I will mention, just as a caution, as the manual says, and I point you to it for guidance and recommendations, you may have to do some manual tweaking of motor parameters to get the motor running optimally for your application. But in many cases, you won't have to. It'll be ready to go. So let's do a demonstration. All right, for our second startup, we're going to use a motor that actually does have a preset in the LT shell list of motor types, so we'll be able to do a much quicker and easier startup. The motor I have is an SEW CMP50S motor. This particular one has a speed class of 4,500 RPM, and it has a system voltage of 400 volts. So I got all that information right off the nameplate. That's all I need to do a startup. I don't have to do anything else with it. I don't have to delve into its data sheet. So let's go ahead and get things set up in LT shell, and then we'll test out our motor. Now, the first thing we need to do is factory default our VFD. So we're going to go up here to the button right here, Reset Parameters to Factory Default. I'll click that and say, yes, I do want to do this. So it's going to reset my VFD. Then I need to go into real-time edit mode. And the first thing I need to do is turn on the extended parameters. So I put 201 into parameter 1-14. Next, I need to pick my motor. So I go down here where it says motor type and parameter 1-16, and I'm going to change it from standard AC motor to my particular motor. So what I need to do is go through my list, and I need to find my motor, and I need to be sure it's the right one. Here it is right here, option 18, CMP50S 400 volts. So I pick that, and LT shell, as you can see, has set a bunch of parameters automatically. I need to just eyeball these to make sure they look appropriate. Motor rated speed, 4,500 RPM, 225 Hertz, 1.3 amps, 280 volts. Remember, this is the internal motor voltage, which it calculates using V sub P0, so this seems about right. And then parameter 1-01 is also set to 4,500 RPM. I'm going to set a few things here before I check my other parameters. I'm going to set my minimum speed to 450 RPM. This is 10% of the maximum. That's kind of the recommended. Now, you can certainly go to lower speeds, but your servo may or may not behave the way you expect. I'm going to change my acceleration ramp time to 2 seconds and deceleration also to 2. I'm going to keep my stop mode select at ramp to stop. Everything is fine there. I'm now going to do just a quick check of all the parameter groups that have changes. I'm going to go to group 2 here. And I can see that actually I've got a weird parameter selection here. This preset is set to a speed faster than the motor's maximum, so I'm just going to change that to 4,500 RPM just so I don't accidentally use it. I'm going to roll down here. I am set to 8 kilohertz. That is fine. I could set it higher if I wished, but we'll just leave it there for now. Parameter group 3 doesn't have anything changed in it. Parameter group 4, however, when I click onto it, does turn red, and it has selected the PM motor speed control, so everything's good there. I'm not using a brake, so I'm not going to worry about these three parameters down here, and I'm going to leave the vector speed control gain and integral time constant alone. These are expert parameters, so I don't want to mess with them unnecessarily. Group 5 doesn't have anything. That single change in parameter group 6 is just fine. We'll just leave it. Group 7 certainly does have changes to it. These are automatically set. These are expert motor parameters. I'm not going to mess with them at this stage. They're probably fine. And group 8 and 9 don't have anything changed. So that's everything. I should be ready to run my VFD, but I do need to do one final thing that I almost forgot to do. I need to change to keypad control mode because I do want to use the keypad to test my VFD. So that's it. I'm going to turn real-time editing off now, go over to my VFD, and fire it up and see if I can run my motor. All right, well, we are done with our setup in LT shell. We're now ready to test the motor. We don't have to do an auto tune. All we have to do is enable the motor by removing safe torque off, turning digital input 1 on, and then we'll go to the keypad and we'll ramp it up and down a few times and make sure it works. So here we go. Okay, well, our VFD is showing PDEF. That's because we factory defaulted it, so we need to clear that message by pressing stop. So we'll do that, and now we'll take it out of controller inhibit by turning the 2 safe torque off switches on, and we'll enable it by turning digital input 1 on, and we should be ready to run now. So we'll press the start button on the keypad, and that's going to take us up to the minimum speed, which is 450 RPM. Now we're on Hertz display here, so I need to press the navigate button a few times to cycle around to RPM. There we go, 450. So that's our minimum speed. Let's accelerate our drive. We'll press the up button and we'll take it all the way up to 4,500 RPM to make sure we can get there and that the motor runs smoothly. And that seems to work. Let's reverse direction. We'll go the other way, so we'll decelerate down and reaccelerate up to 4,500 RPM counterclockwise. And that appears to be working just fine. So there we go. All right, let's slow it down. And there we go, we're at our minimum speed again. I'll reverse direction and bring it to a stop. And that's it. Everything seems fine. All right, well, we're almost finished here, but I do want to mention one final thing before we wind up the course. It is possible that you will encounter a MOVITRAC LTP-B model, which goes by the name MOVITRAC LTX. What is this? I want to explain this. It's actually just a plain old MOVITRAC LTP-B, but it has a special module installed in it right here. This is called the LTX module. And what it is a hyperface type encoder interface. It allows you to connect up a hyperface encoder equipped motor. This is something SEW Eurodrive offered in the past. It is discontinued. We no longer sell it, but you may find these out in the field. And if you do, I want you to know what they are. So that is what this option is. The Group 8 parameters control this module. We haven't gone into Group 8. This is a discontinued feature, so we're not really including it in this training. But if you want more information about this, if you actually have one of these and need to get it up and running, Group 8 is the parameter group you mostly use for this, and I point you to the manual which does talk about this feature. So just wanted you to know what this is if you encountered it. And with that, we're going to wind up the course. Just a reminder as we wrap up, if you have any questions about this course, you are more than welcome to contact the training department. Our email address is training@seweurodrive.com. I do ask you to include MOVITRAC LTP class in the subject line. That causes the email to go to the right person to answer your questions, and we will be more than happy to help you out with this class. With that said, I'm going to just give the little caveat I always include. The training department is not a technical support department, so we cannot provide assistance with your specific applications, nor can we help you troubleshoot your specific problems. If you have these, you need to contact your local SEW Eurodrive representative for help. This might be the nearest regional engineering office to your location, your district sales manager, or possibly your distributor. So I point you to them for those kind of questions. But if you have any question about the class itself, email us. We'll be more than happy to help you. And with that, we end session 13 and the class. Really good job for hanging in with us, for learning a lot about this VFD. You deserve a few gold stars. I hope you found this class helpful, and I look forward to seeing you in other classes in the future. So, have a great day, and hope all goes well with your MOVITRAC LTP-B.